Hi, I'm Junhao. My final project is about drug reviews sentimental analysis. This project has 6 content: introduction, columns of datasets, visualization, data preparation, model selection, and conclusion. Let's begin with the introduction. This dataset is a public dataset from Kaggle. The link is here. It is about patient reviews on specific drugs along with the related conditions and a 10-star rating. I plan to build a model to predict patients' satisfaction on specific drugs based on their reviews. There are 7 columns in this dataset. It contains what the drug's name, what the drug is used for, people's reviews and people's rating of the drug, and how many users who found the review is useful. Okay, let's see what are these drugs mostly used for. Here is the top 10 most common condition graph. We are familiar with these most common conditions like birth control, depression, pain, weight loss. It makes sense that something like birth control would have more reviews than something less happened. So how does the rating of these drugs perform? We can see the rating distribution map, and it seems that most ratings are centralized on 1 or 2 and 8 to 10. This phenomenon can reflect that people write reviews for specific drugs that they really like it or they really dislike it. So how does these drugs perform in terms of medical efforts? Are these drugs mostly used for? I calculated the average useful count number and can compare it with the rating. So I create this graph. It is not hard to find that reviews with higher scores seems to have more useful count number. Here is the data preparation. Now I'm curious about what makes a useful review. Before we build our model, we have to quantify our review data first. The review data is the text data. I use TF-IDF method to finish quantifying the data. TF is normalized term frequency, and the IDF is the inverse document frequency. This slide shows how to compute TF and IDF. The formula is here. And how to do this in Python. Oh, by the way, before we do this in Python, we have to import the NLTK package first, or this will not work. Now we need to select our model. The first model I use is Navy Bayes classifier. I test the Navy Bayes in a binarized version of the rating column to try to determine which comments are most favorable. The total rating star is 10, and I setting 5 as a boundary. Finally, the accuracy of Navy Bayes classifier is up to 72%. Actually, it is not a very high probability. The second model is random forest classifier. This is the code. Actually, I imported sklearn package in order to use this classifier. I think sklearn is a good package that it offers us many machine learning algorithm. In this case, its accuracy is up to 79%. Compared with Navy Bayes classifier, which accuracy probability is 72. The random forest classifier gives us a roughly 7% increase in the accuracy of our classifier. The last model I use is neural network. Neural network is often used for big amounts of dataset. Actually, it is very suitable for our dataset. Our dataset exactly has 160,000 training examples and 50,000 text examples. I set 3 columns to present patients' attitude to drugs, where 0 is negative, 1 is positive, and 2 is neutral. I said that if the rating is more than 8, then I consider it positive. If it is more than 5 but less than 8, I consider it neutral. On the left, I consider it negative. The final accuracy is up to 89%. I think this model is the optimal model compared with the previous two classifier, Navy Bayes classifier and random forest classifier. The purpose of this project is to predict patient satisfaction to drugs based on their reviews. I use 3 methods, and I found the optimal model is NN classifier with careers. It has an 89% accuracy. Now we already have the model. Once we have new reviews to drugs, we can still use this model to predict the rating or predict the attitude of its user. Here is the reference, and this is the data source. Thank you.